Hello students, welcome again to my channel DNA.12 Education. Students, today you are going to continue our material about matrix. Matrix part 3, the inverse of matrix. Mathematics series, Matrix 3, the inverse of matrix. This video is presented by DNA.12 Education. Okay, students, before we go to the inverse of matrix, the first we are going to discuss about identity matrix and singular matrix. The identity matrix is a square matrix that has ones along the main diagonal and zeros for all other entries. Once again, the identity matrix is a square matrix that has 1 along the main diagonal and zeros for all other entries. Look at the matrix below. This is the identity matrix for matrix 2 times 2. One along the main diagonal. 1 along the main diagonal, and the rest zeros for all other entries. Okay, look at the next example. Matrix B. This is the identity matrix for matrix 3 times 3. 1 along the main diagonal, and the rest zeros for all other entries. Zeros for all other entries. So the identity matrix is a square matrix. The identity matrix is a square matrix that has 1 along the main diagonal and zeros for all other entries. Is it clear to you about the identity matrix? Good. Now we go to the singular matrix. A singular matrix is one which is non-invertible. Means matrix determinant is 0. A singular matrix is one which is non-invertible. Means matrix determinant is 0. Okay, we go to the next example. Let matrix A 2, 4, 3, 1. Matrix A 2, 4, 3, 1. And matrix I, we call this identity matrix, is 1, 0, 0, 1. Identity matrix 1, 0, 0, 1. Matrix A minus K identity matrix is singular matrix. Find the value of K. Okay, students, we are going to answer this question. The information is A is 2, 4, 3, 1 and identity matrix is 1, 0, 0, 1. A minus K identity matrix equal, open the bracket, this is the matrix 2, 4, 3, 1 minus k, open matrix, 1 0 0 1, close matrix. And then we're going to continue, equal, open matrix, 2 4 3 1, and then this is the scalar. You have to times inside, minus, open matrix, k times 1 is k times 0 is 0, k times 0 is 0, k times 1 is k, close matrix. Next, we can simplify this matrix. 2 minus k, 2 minus k, and then 4 minus 0, 4, and then 3 minus 0, 3, and the last is 1 minus k, 1 minus k, close matrix. Is it clear, everyone? Okay, the information is A minus K, I is singular matrix, right? Singular matrix. A singular matrix means the matrix that has determinant equals 0. Singular matrix means the matrix that has the value of the determinant is 0. So, the matrix 2 minus k, and then 4, 3, 1 minus k, means this matrix has the value, determinant value is 0, right? Determinant is 0. Okay, what's determinant? Okay, we're going to review again about determinant here. All right, diagonal minus diagonal, we call that determinant of matrix, right? Okay, we can continue. So the first diagonal, the blue arrow, sorry, the green arrow is 2 minus k times 1 minus k minus, and the red arrow, 3 times 4 is 12 equal 0. Is it clear to you? Okay, now we're going to use the algebra concept, this one right here. Right? 1. So we'll find 2 times 1 is 2. 2 times minus k minus 2k. Minus k times 1 is minus k, and then minus k times minus k is positive k squared, minus 12 equals 0. So we can simplify here, 1 k squared, and this one is minus 3k, and then 2 minus 12, right? So we got minus 10. Equals 0. Now we're going to factorize this equation, k squared minus 3k minus 10 equals 0. Okay, so we can factorize 0. Here is k, this one is k, and then negative means positive, negative, right? Because the c is negative, so the sign is positive and negative. Okay, different sign. And now we go to find the factor of 10. Okay, the factor of 10 is 5 and 2. Okay, and then you have to prove this one, this equation is correct, right? So now we're going to divide to two parts. So k plus 2 equals 0, or k minus 5 equals 0, right? So k equal minus 2, or k equal 5. Clear, everyone? So the value of k is minus 2, or k is 5. That's very easy, right? Single matrix and identity matrix. Okay, next. The inverse of matrix. The inverse of matrix A is A to the power minus 1. That's the symbol of inverse of matrix. Only when matrix A times matrix inverse or inverse matrix equal A to the power of minus 1 or inverse matrix times matrix A equal identity matrix. Okay, students? So this one is identity matrix. Okay, students? This one is identity matrix. Once again, matrix A times inverse matrix equal inverse matrix times matrix A equal identity matrix. In order to find the inverse of 2 times 2 matrix, there are 2 steps to follow. Step 1, swap the position of A and B, put negative in front of B and C. Swap the position of A and B, put negative in front of B and C. Let's say we have matrix 2 times 2 here, okay, and this is the component matrix A, B, C, D. Clear one? The first step is swap the position of A and B and then put negatives in front of B and C. So you have to swap this component matrix. Okay, you have to swap. Okay, so it will be here is D and here is A. Okay, swap the position of A and B and then put negative 1 and put negative here in front of B and C. So you just insert here the negative 1 here. Okay, here 1. So it will be negative here, negative, negative. Here is negative C and here is negative B. So you don't need to swap C and B. Swapping elements will go to A and B element, but the rest just put negatives in front of B and C. Is it clear to everyone? Once again, okay, this is the inverse of matrix, right? Everyone? This is the first step. Swap the position of A and D and put negatives in front of B and C. You can see? And the step 2 or the second step is divide everything by determinant AD minus BC. Once again, step 2, divide everything by determinant AD minus BC. So the final answer for the inverse of matrix A the power of minus 1 or inverse of matrix equal here is divide by determinant, okay? Divide by determinant here. So the inverse of matrix A is 1 over determinant of A upper matrix, yeah, and then follow the step, and then we have to copy this one, so it will be B minus B minus C and A. So this is the final answer for the inverse of matrix. Is it clear to everyone? Okay, to make sure everything's clear about the inverse of matrix, we go to the next slide. Okay, the inverse of matrix. Look at this diagram. Let matrix A, B, C, D. This is the matrix we can do. Okay. For AD elements, swap the position A and D. And for B and C elements, put negatives in front of B and C. So the inverse of matrix is A the power of minus 1 or inverse of matrix A equals 1 over determinant A open matrix B minus C and A close matrix. The inverse of matrix A is 1 over determinant A open the bracket open matrix B minus C A close matrix. Okay, example 1 to make everything clear about the inverse of matrix. We go to the example 1. Let matrix A 8 minus 3 7 and 0. Find the inverse of matrix. Go. Matrix A is 8 minus 3 7 and 0. Determinant of A is the absolute value of A, B, C, D. This is the formula, right? Diagonal minus diagonal. So determinant of matrix A is AB minus CB. So determinant A or absolute A is 8 times 0 minus 7 times minus 3. We got determinant A is 21. So what about the inverse of matrix? Let this is matrix A, B, C, D. So the inverse of matrix is 1 over determinant A open matrix B minus C A close matrix. So matrix A minus 3, 7, 0. So the inverse of matrix A is 1 over 21, open matrix, 0, 3, minus 7, and 8. 1 over 21, open matrix, 0, 3, minus 7, 8. Or we can simplify. The inverse of matrix A is 0 over 21, 3 over 21, minus 7 over 21, and 8 over 21. Then 0 over 21 is 0. You can simplify, okay? Next, we go to the example 2. Let matrix A 26 minus 6 minus 9 and 2. Find the inverse of matrix below. Matrix A 26 minus 6 minus 9 and 2. The first step you go to find the determinant of matrix A. This is the absolute A, B, C, D. Diagonal minus diagonal. So determinant of A is AD minus CD. Right? So determinant A is absolute value of A, 26 times 2, minus, open the bracket, minus 9 times minus 6, close the bracket. So determinant of A is 52 minus 54. We got minus 2. The inverse of matrix, let A, B, C, D. So the inverse of matrix A is 1 over determinant of A, open matrix, B minus B minus CA, close the matrix. Okay, once again, the inverse of matrix A is 1 over determinant A, open matrix, B minus B minus C, A, close matrix. So matrix A 26 minus 6 minus 9 and 2. We'll find the inverse of matrix A is 1 over minus 2, open matrix, 2, 6, 9, 26. Okay, we can simplify this matrix by inserting minus a half to the inside of the matrix. Now we have matrix. Now we have the inverse of matrix A is minus 1, minus 3, minus 4.5, and minus 13. We can times all the components in the matrix by this column, minus half here. So minus a half times 2 is minus 1, minus a half times 6 is minus 3, right? Minus a half times 9 is minus 4.5, and minus a half times 26 is minus 30. Is it clear, everyone? Okay, this is the last material for the inverse of matrix. To make sure everything is clear about the inverse of matrix, now we go to the practice. Okay, students, now it's your turn. Good luck.